So in this chapter we're going to see tree algorithms. Okay, three. In linear data structure, data is organized in sequential order and non-linear data structure. Data is organized in random order, sequential and random order. Okay, so tree. Tree is a very popular data structure used in wide range of application. A tree data structure can be defined as follow like tree is a non-linear data structure which organizes data in hierarchical structure. Tree represent the nodes connected by edge. So tree here is called root, okay, and this is the parent node. This both is a parent, and this called sibling, okay. The single is a child, D is a child, E child, D is a sibling, okay. A is a root, B and C called parent, E F sibling, F child of C, and G is child of C. So root, okay. In a this is called root, okay. In a tree data structure, the first node is called as root node. In the tree, जो भी data structure का first node होगा उसे हम बोलेंगे root. In tree data structure, the first root is called as a root node. Every tree must have a root node. Every tree must have the root node. Root node is the origin of the tree data structure. In any tree, there must be only one root node. We never have multiple root node in tree, okay. अगर suppose two root का होगा combination तो is called one first tree, second tree, not one tree, okay. In every data structure, tree must be on, there must be only one root, okay. Then this is about the root, okay. First node is called the root, okay. Then next is edges, okay. Edge. The edge is another fundamental part of tree. The edge is another fundamental part of tree. In tree data structure, the connecting link between any two nodes is called edge. Connecting link between two nodes is called edge. Okay. So node between two nodes connection is called edge. Then node. Each element, okay, in a tree n number of nodes there will be maximum n minus 1 number of edges, okay. So node, each element in the hierarchical represent is called node. In the about tree, that is node means this A, B, C, D, E, F, G, okay. A, B, C, D, E, F, G, H. The element represent is called node. In about tree you can see this all are A, B, C, D, E, F, G. These all are what nodes, okay. So let's see this path. Path between any two nodes in a tree is sequence of distinct nodes in which successive nodes are connected by edges. So length of path is total number of nodes. Example we can see here in two nodes in a tree is sequence of distinct nodes in which successive nodes are connected by edges. So length of path is total number of node in path. In a below example we can see here, in above example you can see here. So A, B, see this path here, A, B, then E, A, B, E, this is the path A, B, E, then A, C, F, right? This, then this, okay. So what about parent here? What about parent? So in a tree data structure, the node which is predecessor of any node is called parents. Means root का बात जो आता है is called a parent node. Parent node can also be defined the node which has called children. means who's having children, like you can see this is this both having this is the children of B, so it's called parents. Okay, the node which has child or children. The root node is only node which doesn't have parent. In above example you can see B C A B C D E are parent node. Okay, the root node is only node which does not have parent. So see here does not have parents, so it's called A B C. These are the what root node. Okay, then child. The successor of node is called child. Okay, in tree any parent node can have any number of child nodes. In above in diagram you can see D E are child of B. D E are child of B, right? Then sibling. After child, then sibling. Okay, let's see here. Children of the same parent are called siblings. So you can see D E are the sibling of, right? So in single words, the nodes with same parents are called as sibling nodes. So B is the parents of D E. Okay. Then in above example, you can see F G is our sibling. Also D E are siblings, right? Then subtree. Subtree. A structure is a set of nodes and edges of parent and all of the parent. Means if suppose root है, okay, यहाँ पे कोई root होता और parents like this exam diagram structure होता, it's called subtree of subtree. Okay, yeah, you can say that this is a subtree. Leaf node, the node which does not have any child. Node which does not have any child is called leaf node. Leaf node. Now see. Okay, so leaf node कौन सा होगा यहाँ पे? This one, D E F G. This is a leaf node because it doesn't have any child. Okay, it's called leaf node. The node which does not have any child is called a leaf node. Leaf node are also called as terminal node because यहाँ से end हो रहा है, right? Terminal node is called जहाँ से ending हो रहा है उसको बोलते हैं leaf node. Okay, in above you can see this D E F G are the leaf node. Then internal node, a node of tree that has one or more child is called internal node. Means just 1 minute. Internal node. Okay, a node a tree has no one or more child is called internal node. The root node is also said to be internal node. If the tree has more than one node, internal node are also called as non-internal node. Okay, internal node means which having the child. Okay, that is we can say A, B, C, it's internal node. And then external node is the leaf node are also called external node. In above F, G, H, I, J, F, G, then are the external node. Degree of node, then degree of node, degree of node. In a tree data structure, the total number of children of node is called as a degree of node. Means total number of children of node is called degree of node. In simple words, degree of node is total number of children it had. In above tree, A is a C means a degree number. Say A is the degree of node. C is having two children, right? So in about 3 degree, in about 3 degree of a node of A is of node A is 2 degree, right? Why? Because it's having 2, right? Then again, if suppose we put it here like this, mm, okay, then let's copy. paste it, suppose, and change the, okay, suppose. So now we can say that, see, अब डिग्री नोड मीन्स एक पेरेंट्स के अंडर जितने चाइल्ड होगी दिस कॉल्ड द डिग्री ऑफ नोड. सो ए हैविंग टू चाइल्ड, ओके, देन so it's called the 3 degree of a, or node a is 3, then a 3 degree of a node, suppose c is again 2, sorry, 2, here you can see c having 2 nodes, right? Then 3, okay, then 3 degree of a node b is 3. Why? Because b is having 3 children, right? So what, in tree data structure the total number of children of node is called degree of node. So we know now what's the degree of node, right? A degree of tree, a highest degree of node among the all nodes. This means जिसमें highest degree इसको कहते हैं degree of tree. Degree of tree means degree of tree. So यहाँ पे degree of tree क्या होगा? B, because B में ज़्यादा highest children है, right? Like this. Then level. Then level. So level में क्या होगा? In a tree data structure, the root node is said to be at level 0, and children of root node is level 1, and children of root node is level 2. See, listen. This is 0, 1, right? We will be level 2. This is level 2. 0, 1, 2, like this level, okay? Then higher, the highest of depth of node, the highest any node in length of longest part from the node terminate is called highest node. Highest node मतलब suppose यहाँ से start होने के बाद suppose यहाँ पे भी नीचे होगा, suppose नो चिल्ड्रन होता है, लेकिन जहां से एंड हो रहा है पाथ कंटिन्यू होके उसको बोलते हैं हाईएस्ट डेप्थ ऑफ नोड, ओके. एंड डेप्थ ऑफ 3 मतलब टोटल नंबर ऑफ एजेस फ्रॉम रूट node to leaf node at the least at the last level is said to be depth of 3. Depth of highest is the same for the tree, but the difference between 3 is highest always measure, okay. So here depth of 3, okay, listen, let division first this tree, then you will get better, okay. uh, okay, see what we can say here. We will make again diagram, and I will tell you the depth, level and all, okay. So see first, tree is nothing but is a, we can say a tree is a non-linear data structure which organizes data in hierarchical structure. We have already studied about linear and non-linear in data structure subject, right? So I hope you know the meaning of the linear and non-linear, right? So here tree, so it's having like root, edges, node, path, parents, child, sibling, subtree, leaf node, internal node, external node, and degree of node, which we have seen now. Degree of tree, level, highest of depth of a node. So root, we will revision again this point. Okay, root in a tree data structure, the first node is called root. Okay, every tree must have root node. So हर एक ट्री में रूट नोड होता है. Root node is the origin of tree data structure. In any tree, there must be only one root node. We never have multiple root node in a tree. Okay, हर एक ट्री में एक रूट नोड होता है. Then edges or edges is another fundamental part of the tree. In tree data structure, the connecting link is between any two nodes is called edges. Okay, connecting link between two nodes is called edges. Okay, ये link connect हो रहा है, right? Is called then edges. Node. Each element in the structure representation is called a node. ओके हर एक स्ट्रक्चर में जो रिप्रेजेंट कर रहा है उसको बोलते हैं नोड, जैसे कि ए बी के डी ई सी जी एफ. सो दिस इज कॉल्ड नोड. देन path. a, a path between any two nodes in a tree is a sequential of distinct nodes in which successive nodes are connected by edges. Okay, so after this parent in a tree data structure, the node which is predecessor of any node is called parent node. Parent node can also be defined as a tree node which has child or children. The root node is only node which does not have any parents. In the above tree, node A, B, C, D are parents. Okay, A, B, C are the parents here. Okay, then child. The in tree, any parent node can have any number of child. In above, we can see that D, E, K, F, G, child. Then sibling, child of the same parent. See, abja K, D, E is a sibling of sibling, right? Because it's having one parent, three of them having one parent, that is B. So it's called sibling. Okay. This is not E and F is not sibling because इनके parents same नहीं. Okay. But B and C is a sibling because A, B और C के parents. Okay. So children of the same parents are called sibling. In simple word, in nodes with same parent are also called sibling node. So I have already explained the example siblings, right? Subtree. A subtree is a set of node and edges of parent and all. You can say suppose A है, then यहाँ पे कोई ट्री होता, so A इसको हम बोल सकते थे सब tree. Okay, then leaf node, the node which does not have any child is called leaf node. So K D E F G. So leaf node क्या होगी यहाँ पे? leaf node K D E F G. K D E F K D E F G. So this is a leaf node and sibling or B के sibling first is a K D E. Sibling parents कौन इसके? B, right? Then next sibling is what? F and G, right? And F G. Parents F G. कौन parents इसके? C, right? So ये दोनों sibling हुए और ये दोनों sibling हुए, right? Then child K D E child K D E child. So K D E so you can say G F are the childs, right? Then parents is A B C. You can say A is the parents of B C, then B is the parents of K D E, then C is the parents of what? C is the parents F G, right? F and G, A B C, right? Then subtree is not there here now. Then degree of node, I said okay, 3 degree of node A is a 2. Then this is the degree of मतलब how अभी जैसे B की degree 3 है, so is the highest degree, right? So we can say that degree of 3 is a B is a degree of 3, right? Then label we have no. Okay, so this is about the series. So let's see the one example. Let's take here. Depth is a
डिग्री कैसे फाइंड किया समझा? अब्दुल्ला, अफरा, भूषण, फैजान, रुतुजा, सौरभ बोलो। डिग्री ऑफ नोट समझा?
Yes, ma'am.
ओके।
You can say um, depth G starting C where it is. So you can say A is a depth is level 0, right? A is a level 0. Okay, you can say 0 depth, right? 0 depth. Okay, 0 depth. Then this is next is depth 1. Okay, I will write 1D, that is depth 1. Okay, 1D, that is depth 1. Okay, 1D, that is depth 1. Then you can say depth 0, depth 1. After you can say C, start from 0 1, right? Then this is 2, again this 2, because this 0. Okay, 1 2, right? Then this is 3. Okay, depth 3. Okay, so this is about the your depth of 3. The total number of edges from root node to leaf node at the last level is said to be depth of 3. Depth or highest is same for the tree but different between this highest. Okay, um, okay. So now let's see the what is binary tree here. Binary tree. Okay, so binary tree is a defined on finite set of nodes um, that either a contain no nodes compounds of. So binary trees का diagram भी ऐसे ही होगा, like suppose A, then let's copy it. Okay, then paste, paste, paste. Okay, you can see here. Suppose this. Okay, then again copy, paste, paste. Okay, suppose we have pasted too much. Okay, then like this only diagram is there. Okay, so A B C. Okay, like this you can keep. Okay, so किसी भी फॉर्म में आप इसको बाइनरी ट्री को डायग्राम बना सकते हो. Okay, like this you can change the name like B, then you can give the name C. So this is like of course tree only. D, E, and F. Okay, so give the link of this tree. Okay, so I'm giving like this connection, then connection, connection, then this is called the link. Okay, these are the parents of E and F. Okay, so this is the type of binary tree. Okay, so here how to represent the binary tree, array representation and linked list representation. So array में binary tree representation होता है और linked list में होता है. In array representation of binary tree, we use one dimensional array to represent the binary tree. Consider above example binary tree. Okay, so binary tree हम लोग one dimensional array में, you know very well, just 1 minute, हमने अरे ये हमने डेटा स्ट्रक्चर में ही स्टडी किया था एंड मैंने ही आप लोगों को ही समझाया था, राइट? अरे हाउ टू डू अरे लिंक लिस्ट एंड दिस ऑल. So see, binary tree ये टू फॉर्म में रिप्रेजेंट होता है, एक अरे एंड ए डेटा स्ट्रक्चर रिप्रेजेंटेशन. ओके, सपोज लाइक दिस. नाउ जो भी हमने नेम पास किया है, लाइक ए बी सी डी, ए बी सी डी, okay, a b c d e, whatever we pass the data, like then suppose dot dot dot. Okay, फिर जो भी end होगा, right? So okay, so ये array representation में data ये binary ये array representation और linked list representation होता है. Okay, to represent binary of text and using array representation, and linked list means link list means link list. लिंक लिस्ट में कैसे होगा देखते हैं. ओके, सो सपोज लिंक लिस्ट, सपोज this like. Okay, so we can say the left child address, then data. Okay, left child, you can see here left child address, data, and right child address. Okay, left child address, okay, left child address, then data, data, and right child address, RCA right child address, left child address. ओके, सो ये रिप्रेजेंट होता है लिंक लिस्ट में. ओके, सो इन माय नेक्स्ट लेक्चर वी विल सी how to present binary like that is array representation and array data what linked list representation. So linked representation is nothing but we use a double link list to represent binary tree. In double linked list, every node consists of three field. First field for storing left child, then address, second of storing actual data, and third is storing the right. Okay, in above you can, in this table you can see this represent linked list. Okay, सो अगर ये डायग्राम है बाइनरी का, ठीक है, सपोज ये बाइनरी डायग्राम है. सो यहाँ पे यू कैन सी ए बी डी, राइट, देन यू कैन से सी ई एफ. तो ये हम लोग किसमें रिप्रेजेंट करेंगे, इन द फॉर्म ऑफ टेबल. सपोज सी लाइक दिस, हमने सपोज टेबल बनाया. ओके, हियर वी हैव टू प्रिपेयर. ओके, सपोज then we have to prepare this table, like we have to make. Okay, here we have to write a. Okay, so a, क्योंकि मैंने क्या कहा लिंक लिस्ट में क्या होता है, लेफ्ट राइट एंड बीच में a is you know even root, right? Then we will write here again, we will take, let's copy this only. Okay, paste here. Okay, then suppose, okay, we copy here, then again paste. लिंक लिस्ट की ट्री डायग्राम ऐसा आता है. ओके, ओके, सब एग्जांपल सपोज. ओके, so like this. ओके, सो यहाँ पे होगा बी एंड यहाँ पे सी, और इसके नीचे जो भी चाइल्ड होगी उनकी इंफॉर्मेशन. ओके, सो बीच में लेफ्ट चाइल्ड राइट चाइल्ड जो भी आएंगे यहाँ पे वी विल पुट. ओके, राइट चाइल्ड ये रूट, जैसे कि लेफ्ट चाइल्ड राइट चाइल्ड एंड मिडल वन इज डेटा, कि ए का डेटा क्या है, लेफ्ट एंड राइट चाइल्ड इसका डेटा क्या है. ओके, सो दिस इज अबाउट द लिंक रिप्रेजेंटेशन, डेटा रिप्रेजेंटेशन. दिस इज अबाउट द बाइनरी ट्री. बाइनरी में मतलब बाइनरी डेटा स्ट्रक्चर अरे रिप्रेजेंटेशन और लिंक रिप्रेजेंटेशन में कन्वर्ट होता है. इसलिए इसको मतलब जो ट्री है उसका कन्वर्जन हम अरे एंड लिंक लिस्ट में करते हैं. इट्स कॉल्ड बाइनरी ट्री. ओके, एंड normal tree we study this, right? So today's lecture over here. Thank you.
एनी प्रॉब्लम? लेक्चर समझा? यस बोलो. कुछ प्रॉब्लम, कुछ पॉइंट समझा नहीं हो, कोई कॉन्सेप्ट क्लियर नहीं है?
नो मैम, समझा मैं।
समझा? ओके, जस्ट 1 मिनट।